Good morning, guys. Today we're going to take a look at fractions that are greater than one whole. So this is something that we've already learned about, just like everything else that you're studying now. This is all a review, but you probably need the reminder. So let's take a look. So just like fractions that we started with earlier in the week, fractions that were part of one whole, fractions that are greater than one whole use the numerator and the denominator. And listen to the words that I'm saying. Greater than one whole. How many whole circles do we have here? 2 whole circles, right? All of the fractions that we see are going to have either more than one model, or they're going to go past 1 on the number line. Okay, so that's what we mean when we say fractions greater than one whole. More than one model, shaded, or going past 1 on the number line. So let's take a look. Your numerator and your denominator, the definitions have not changed. Okay, your numerator is still the number of shaded parts in a model, and your denominator is still the number of parts in, and I had to put this down here because I forgot, the number of parts in one whole. That's very important. So let's go ahead and write a fraction for this first model. Take a look. So we have 2 circles, okay? And the first thing we want to do is write a denominator for them, which is the number of parts in one whole. And that's very important. And you know, in class when I read this, I would go one whole, right? How many parts are in one whole here? Just one circle. Let's check and see. One whole has 1, 2 parts, right? So my denominator is going to be 2. Now my numerator is still the easy part. My numerator is the number of shaded parts. How many parts are shaded? And this time we're going to go ahead and look at both, okay? So for your denominator, you're only looking at one whole, but for your numerator, you're going to count the shaded parts total in both models. 1, 2, 3. 3 parts are shaded, 2 parts in one whole. When we write a fraction greater than one whole, you're always going to find that the larger number is on top of the fraction, okay? Let's take a look at this model below. We want to go ahead and write a denominator for this fraction. So we remind ourselves of the definition of a denominator. That's the number of parts in one whole. How many parts are in just one of these models? 1, 2, 3, 4. So my denominator has to be 4. My numerator is going to be the number of shaded parts. So I'm going to go ahead and now I'm going to count the shaded parts in the entire picture. 1, 2, 3, 4, 5, 6. So my numerator is 6. So I have 2 different fractions here, 3 halves and 6 fourths. Both of these fractions represent fractions greater than one whole. Okay, and both of these fractions have a larger numerator than denominator, right? 3 is bigger than 2, 6 is bigger than 4. So today during this lesson, we want to find that our numerator is going to be larger than our denominator. Let's look at some more examples of fraction models greater than one whole. Okay, so again, I start with my denominator just like I do when I'm writing out regular fractions. And my denominator is the number of parts in one whole. So I'm not going to count. This is the mistake kids make. They go 1, 2, 3, 4, 5, 6, 7, 8. How many wholes did we just count? 1, 2, 3, 4, 5, 6, 7, 8. We counted both wholes. That's 2 wholes, right? We only want to count the number of parts in one whole. Okay? How many parts are in one whole? 1, 2, 3, 4. So my denominator is 4. My numerator is the number of shaded parts in the entire picture. This is where we get to look at both wholes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 parts are shaded, so my numerator is 7, and my fraction is 7 fourths. Notice the bigger number is on top, which is normal for fractions greater than one whole. Take a look at this one on the bottom. This time, how many wholes are in the picture? 3, right? 1, 2, 3. But for my denominator, I only want to count the parts in one whole. How many parts are in one whole? 1, 2. So my denominator is 2. My numerator is going to be the number of shaded parts in the entire picture. So I can go ahead and count those. 1, 2, 3, 4, 5. Is that right? Sorry, 5s are hard for me backwards. 5. So this fraction would be 5 halves, okay? 5 halves. And again, numerator is larger than the denominator. Denominator is the number of parts in one whole. 1, 2, one whole, 1, 2, 3, 4. Okay? Make sure you're thinking numerator and denominator as you find your fractions, especially that the denominator is the number of parts in only one whole. Now let's check out some number lines. Same rules apply here. Your denominator is still the number of parts in one whole. So let's go ahead and find our denominator for this first number line. And this is why circle 0, circle 1, and hop is still so important, right? Circle 0, circle 1, and hop. 1, 2. In one hole, stopping at the 1, not hopping all the way down to here, how many jumps were in one hole? 2 jumps, right? So my denominator is 2. And that's why circle 0, circle 1, and hop is so important. Okay? So I have my denominator 2. Now I need my numerator. That's the number of shaded parts. You could count the shaded parts if you wanted. 1, 2, 3. Or you can go ahead and write the fractions underneath, which I'm going to do for you just because it's, good practice. 0 halves, right? And my denominator is coming from here. 0 halves, 1 half, 2 halves, which equals 1 whole. That's why they're lined up. That's a 2. 2 halves. And 3 halves is where we're stopping, right? We're stopping at the shaded part here. So this number line represents 3 halves. And you can tell that your numerator is 3 because we wrote the fractions underneath at the different points, and because we counted 1, 2, 3 shaded parts. Okay? 3 halves, again, my numerator is greater than my denominator because this fraction goes past 1 whole because it's greater than 1 whole. Let's try this one below. So we're going to go ahead, we're going to write our denominator. To do that, we need to circle 0, circle 1, and hop. 1, 2, 3. Don't hop all the way down there because you're going to mess up your denominator doing that. Okay, we have 3 parts in one whole. We stopped at the 1. Okay, so we know our denominator. Now we want to write our numerator. Now our numerator, we can count the shaded parts. 1, 2, 3, 4, 5. Or we can go ahead and write the fractions underneath, which is a better way of doing this. 0 half, no, halves. Is this correct? No, the last ones were halves. My new denominator is what? Thirds. 0 thirds, 1 third, 2 thirds, 3 thirds. Am I done? No, I'm going all the way down to the end of the shaded part, right? 4 thirds, 5 thirds. Does my denominator ever change? Thirds, 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 thirds? No. Halves, 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 halves? No. Your denominator never changes. The only thing that's changing is our numerator. We start at 0, and then we count 0, 1, 2, 3, 4, 5. So our numerator counts by ones while our denominator stays the same. And we stopped here at the end of the shaded part. So our numerator is 5. So this fraction is 5 thirds. Okay? Let's take a look at 2 more examples and then you're free. Okay. So we're looking at some more number lines. This time on the number lines, they're not shaded. They just placed a star or a point on the number line, and so we're going to tell what fraction goes there. Okay, we start the same as we did last time. The denominator is the number of parts in one whole. So I circle 0 and I circle 1 and I stop, and that's where I'm going to stop hopping. 1, 2, 3, 4. 4 parts in one whole. So my denominator is 4. Sorry, that looks a little weird. My denominator is 4. And now I can go ahead and I can write my fractions underneath, right? My denominator is going to stay the same. It's just my numerator that's going to change. 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths, which equals 1 whole, which is how I know I haven't messed this up yet. Okay. And 5 fourths. Right? So if I had something else under here, let's say my 3 fourths was underneath my 1, I would know something went wrong with my fractions. Now, underneath the star is the fraction 5 fourths, so I know that my numerator is going to be 5. And again, check it out. Numerator is greater than the denominator. That's normal for fractions greater than 1 whole. Okay, let's go down here. Last one, write our denominator. Circle 0, circle 1, and stop, and hop. 1, 2, 3. Don't go hopping all the way down to 2. You're going to mess up your denominator. So my denominator is 3. Okay. And now I can go ahead and write my fractions below. 0 starts with 0 thirds, 1 third, 2 thirds, 3 thirds. My denominator never changes, right? Thirds, 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 thirds. It's just the numerator that's counting by ones. And then 4 thirds. Right? 4 thirds falls underneath my star. 3 thirds falls underneath 1 whole, so I know that I lined all these up right. And I have my final answer, which is 4 thirds. Okay? So today's lesson, just like the last 2 lessons, big focus is on knowing the definition of numerator and denominator. As long as you stick to 1 whole for your denominator, you should be good for today. So I wish you good luck. Please take your time. I know you can do this because you guys were awesome at this year in my classroom.